Hello. Hello. Cool. Let's get at it. Let's get active. So last week what did we do? Yesterday, we got up to effectively a working converter. So if I try to convert 3, 0, 1, 1, if I convert 0, however, 0, cool. So it kind of works. 0 to 8, but now when you convert other numbers greater than 0, your binary starts with that lead than 0, for example. 1, the result is 1, which is what we noticed yesterday, which I wasn't even sure if it was an error or not. It's a feature. Anything about it, 0 and 1 in base 10 always convert to 0s and 1 in base 2, respectively. So you can add another base case to handle when the input is 1. And then else if. It's interesting. So the idea of base cases actually is more a functionality play of the if statement. There is no recursive, like this is the syntax for a recursive function. It's just you're using an if statement within a function that calls itself. Yeah. So recursion is like cool. It's interesting. So we'll add in an else if to the function that checks if input is equal to 1, and if it is, returns a string 1. So else if cool. Okay, that's quite cool. Yeah, so the idea being we've got these two bits for input, which we know we're looking for one of those to be no. So we know if it's 0 or 1, it will always be 0 or 1. And so input will always be input if it's 0 or 1. So we can then just check for, is the input 0 or 1? And if it is, then stringify the input. Well, not stringify, use a string function, or just turns it into an input. So, cool. So, we can just get rid of all of this, I believe. Yes. So if input is that or that, then return string input. The console give us any indication as to what might go wrong. Where are we? Yeah. base case is no if input. Do I have to? Okay. Okay, I had to call it twice. That's interesting. I would have thought I didn't have to do that, and I could just say if input is strictly equal to 0 or input is strictly equal to 1. So if I put that in brackets, would that have made a difference? Just out of interest. Oh. Yeah, okay, cool. Can I do that here though? Do I care? Do I want to? No, not necessarily. Let's go. Circle, let's see. So if it's 0, convert. If it's 1, convert. If it's 65, convert. Oh, no, 3. Or 1, okay. Cool. Okay, we're going to show the animation. Interesting. I wonder if this gets longer the more that we go. Okay. Sorry, we're going to be doing the animation on the number 5. So now we're adding something in the check user input to determine whether or not it is a 5 that's been added. So if we check the input and it is 5, we're jumping into the show animation bit. So dry a is a term that sort of suggests don't repeat yourself, which is a useful principle in coding because the idea is to not repeat yourself. So that's what dry represents. Okay, so we're going to pass that past value to that input int nothing but net. Cool. Okay, so I also like this idea of testing it as we go. Yeah. Gotta be mindful. Cool, so that works. Okay. Set timeout. I feel like I've seen this before. So that's a delay to thinking. Delay works in milliseconds, so 3,000 seconds. 3,000 milliseconds is 3 seconds. That's something I should write. It's probably something I can find in the documentation though. It says milliseconds. Cool. Set timeout. Okay. Callback function will just be why I'm typing it like that now. Not my callback function, my callback function. And then my delay is just 1,000 milliseconds. So within my callback function, I just want to call console log. So you saw the delay there. Cool. Okay. Oh, I did see that actually. I did see that. FreeCamp and then code, yeah. I'm gonna say so let's talk about asynchronous. Cool. Okay. So asynchronous means we can set something and it doesn't have to wait till it's completed. So the callback function is run, and it's after a second that the thing is it's after a second that the call. When you call set timeouts, if I'm thinking correctly, and as I read this, maybe it will come true. If you call set timeout gets ran. Set timeout gets run, but the callback function waits. When set timeout is ran, it calls the callback function. The callback function, however, is delayed by however long before it's executed. Now, once set timeout is called and it does that, it doesn't care about the delay, it then continues with execution of the other, whatever's next, right? And so that's why we get free camp and then code. Because after camp, it's like, okay, cool. That callback is now executed, which is code. And so after the fact. And all the code in the show animation function runs line by line, but because set timeout is asynchronous, free and camp are logged to the console immediately, and then code is logged to the console after 1 second. Always use multiple set timeouts to log free to the console after half a second or 500 milliseconds. So free and then code and then camp. That's the same thing, really. But this again probably won't be the final solution because it's still not nice, really. To have to just have like multiple bits here. It's not the most elegant solution, is it? So now I get I get camp free code because time doesn't work out. Yeah. So this just delays them out just right, where that, oh, I can't clear. Okay, well, I can see it here. So if I go 5, FreeCodeCamp, go. Cool. We're going to start the animation. I'm not going to start the animation. I'm going to wait until tomorrow. So let's call it. Let's yeah, guys, keep coming, keep turning up. Thank you for working with this whenever you do, and I hope what you're turning up for you bring to fruition.